In this video, we're going to take a look at a different kind of motion. So I've already set everything up this time. And as you can see, we're looking at this cart on a track from a different angle. I've angled the track so that it slopes downward from high on the left down to low on the right. And I've already set up my origin so it kind of matches the front of the cart. All right, but the problem is my origin is the y-axis is straight up and down and the x-axis is straight horizontal, but my cart's not going to move that way. My cart's going to move kind of in the x direction and kind of in the y direction, and that's actually something for a later date. So for now, we're going to keep it simple, and in order for me to do that, I want to rotate my x-axis here. Oh, come on, we can rotate. There we go. So that it is kind of parallel to my incline. And that doesn't look too bad. So now my x-axis hopefully will be the only axis that my cart moves on. That's my goal. Okay, so I need to put in my ruler again. So I will tell the computer, look, if I go from here over to here, that's a meter. And it's going to make sure that it's a meter. I'll tell it okay. And then I'm going to start putting some points in. So I'm going to put a point at the front of the cart, and it's going to advance the cart one frame, right? And it doesn't seem to be doing much at this point, right? The cart is hardly moving. In a single frame, there's not much going on at all. So I'm just going to keep clicking points here, letting the cart move, trying to get the very front point on this cart every single time. Let's go. That seems pretty good there. This gets pretty boring after a while, but okay, I fast forwarded through all those points, and as you can see by the motion map down here, that in the beginning, the points are all jammed in really close because the cart is hardly moving. And then toward the middle, the points are starting to get spread out. Let's see if we can zoom in here. Then a little later, they get further apart, and then they get further apart even more. So apparently, the cart starts out slow and gets faster and faster and faster. You can see that from the motion map by the spacing of the points. And if we come over here, let's take a look at this graph this time. So the blue line down here matches up with the blue line of the data, which is the y direction. And remember, I turned my axis so that my cart would not move in the y direction at all, which is why I don't have any y motion whatsoever. It's all zero. So I'm going to click on that and I'm going to get rid of it and only look at the X. Now, does this motion look like the map of a straight line? And hopefully it does not. If I try and put a straight line in there, like it doesn't look that good. I start out above my straight line, I go below the straight line, and then I end above it. That's an indication that this data is on a curve. So let's get rid of that. And let's say we tell LoggerPro up here with this curve fit function that actually we're looking for a curve that fits. Now, I happen to know what this curve is because I've taught this class for a long time now. You could randomly pick curves and try and find one that fits. The problem is you have to find a curve that fits that you can then explain. Okay, so I'm going to try a quadratic equation and I'm going to try the fit. And it looks really nice. Look down here, the correlation is 0.999976. if it were a perfect 1, that means that this function perfectly matches my data. So I've got almost a perfect fit. The reason it's not completely perfect is because I'm a human being and I'm taking data. And I got bored and I'm just clicking. I'm trying to get close, but hey, that's really good data. Or here, you can look at the RMSE, which is the root mean square error. And that is really close to 0, meaning my points matched to this perfect curve almost have 0 error. So that is a good sign. I'm going to hit OK and tell the computer that I like that curve. Now, the next thing that we have to do is to take a look at this curve. And I'm going to start my software again so I can draw on it a little bit. Oops. Pink. Okay. So down here, oops, let's get down here. At this point on the curve, the slope of this line, like if I were to, oops, that's not the slope of that line. The slope of that line is sort of like so, almost, I would say, like a 0-ish slope. Why is it 0-ish? It's pretty flat, almost like that, because the slope of this line tells you the speed. And if you remember in the very beginning, the cart was hardly moving. I had just let it go, and so it was slowly picking up speed and it started from a stop. If we take a look at the slope here seems to be a lot steeper. And because the slope is equal to the speed, a steeper slope means a higher speed. So my slope is going from almost 0 up to some positive value. So I'm getting a positive speed. Can I say that I have a positive velocity? Sure. But I have a positive velocity because I told my software down here that this was the positive x-axis. If I decide to flip over my reference frame, I could have gotten a negative speed. Now, Logger Pro is really nice to you in that it will graph x-axis like this, or I can also ask it to graph my x velocity. And if I do this, let's get rid of all these marks. The data seems to be all over the place, but if I put a nice line through there, I get a correlation that's 0.97, which means that line fit to those points is about 97% correct. And my error is 0.04, which does seem pretty low to me. That tells me that my speed this time, since it's a speed versus time graph, my speed is constantly getting higher. There's a constant slope, so every frame, my speed gets faster by the same amount. Okay, and it turns out that each second, my speed gets higher by 0.28. So I get 0.28 meters per second faster every second. So if I come up here and write some stuff again, where's my cursor? Oops, sorry guys. So here, oops. Okay, sorry about that. My slope, come on machine. My slope is equal to, oh, it's not going to do it for me. So despite the technical difficulties here, my slope is equal to my rise over my run. So let's see if I can do it with my trackpad here. Rise over my run. That's not too bad. Boom. Over run. Okay. But this time, my rise over my run, I'm rising down here in speed. So I have a speed, and I'm running in time. And what we're going to find out is that is also a named quantity. And we're going to call that quantity an acceleration. Sorry, that's an ugly looking A. Let's say acceleration is equal to a speed divided by a time. And since my slope is constant, that means my acceleration is constant. So every second, I increase my speed by the same exact amount. Okay, so things you need to take away from this video. If you get a curved graph here, that tells you that your speed is changing. So if your position versus time graph is curved, your speed is changing. And if you get a speed graph that is straight, that tells you that you have a constant acceleration, that your speed constantly increases or decreases by the same amount.